risk difference is one of our very first attributable risks that we're going to calculate. And what this is really doing is looking at the difference, the absolute difference in hard number of cases if you are in the exposed category versus if you're in the not exposed category. For instance, if you're in the exposed category, how many more cases of the outcome are we going to see than if you were in the not exposed category? And that's what this is calculating. So, how do we calculate this? RD equals IE minus INE. I'm just going to stick with the same colors to keep us focused throughout this. So how do we calculate IE again? We have to go and we have to look at our incidence in the exposed, right? So incidence exposed, number, new cases exposed, divided by total exposed minus number new cases. And then we're looking at this row down here, by the way. Non-exposed over total non-exposed, and that's how you would get RD. So how do we fill this in? Well, we know our number of new cases in our exposed is 7. For total exposed, 1 over 131 minus number of new cases, 1 over 79 over total exposed equals. So when you do this math, one of the things that you'll quickly see is that the number comes out to be really, really small. So if you did this, you would end up with let's go 0.040776, and that doesn't really make much sense to people. So as a result, typically speaking, when we're calculating risk differences and population risk differences, we'll have a multiplier. In this case, our multiplier for all our other things was per 100. And so we'll do per 100 too. So rather than this, what we would have is our equation look like this. So when we're doing this per 100, you want to put these in brackets. So the first thing you want to do is subtract these. Then you want to multiply by our multiplier, which is per 100, equals, and you come up with 4.1. 4.1. Now, if you had not used the full numbers, for instance, you know how we went back in and recalculated everything? We used these fractions rather than just going in and saying 5.3 minus 1.3, which would have been really easy to do, right? You end up with 4. But you can clearly see the reason I don't want you to use those final answers is because we already rounded both of these numbers over here, right? These are both rounded numbers after using a multiplier. And you'll see that the answer is not equivalent, and it's off because we rounded before. So if you used your rounded numbers, you're going to end up with the wrong answer. That's why I want you to always plug in all of the information in the equation again so you can get the correct answer of 4.1 rather than 4. So what does it mean to be 4.1? Because that's not the full answer. We've seen that over and over again, that 4.1 is not an answer unto itself. Right? So what's the answer? 4.1 cases of wound infection per 100. What does that mean? That means if those individuals who had incidental appendectomies had 4.1 more cases of wound infection per 100 people than those individuals who did not have an incidental appendectomy. 4.1 more cases if you were exposed than if you were not exposed.